Okay, good morning, everyone. Today I will present this paper titled Evidence of Dark Oxygen Production at the Abyssal Seafloor. In the deep sea, there are no sunlight and dark, so people would think that there's no oxygen, there's nothing. But however, in this paper, the researchers found a surprising discovery. The oxygen could be introduced in the deep sea, and they called it dark oxygen. And we should know why oxygen is important in the ocean. The first, oxygen can control respiration, and oxygen also control marine ecosystems. And the oxygen also play an important indicator of oxygen health. And in this image is the polymetallic nodules in the deep sea. And the nodules contains a lot of metals like manganese and iron. And the research believe that polymetallic nodules would be a potential source of deep sea oxygen. And this study conducted in the chlorine krypton zone, also known as CCZ, and the water depth is 4,000 to 5,000 meters. And there is a mountain of nodules. So this region is a perfect place to do a chemical activity. And then is in situ experiment. In situ means that the experiments were conducted directly on the seafloor. And benefit chambers were deployed to enclosed sediment areas, like this image. And oxygen concentration were monitored over time by using microprofiling, which can provide oxygen concentration profiles across the sediment and water interface. And then is ex situ incubation. Ex situ means that samples will be tested in laboratory conditions outside the nature environment, and the oxygen concentration also were monitored over time by using the optosensor. And the optosensor can continuously monitor during incubation, and the results will be validated by using Winker titration. The Winker titration is the method determining oxygen concentration through a chemical reaction. And the researcher wants to know the source of oxygen. So they use the two methods. The first one is microbiological sampling. These methods analyze microbial community to determine whether microbes could produce oxygen. And the second one is electrochemical measurements. And this method measured electrical potential on nodule surfaces to determine whether nodules could generate oxygen. And during the Benedict chamber and oxygen microfilling, the researcher found unexpected things. The oxygen concentration not only didn't decrease, but actually increased. In the 25 chamber incubation, the oxygen concentration increased from 185 to 200 or more. So this result pushed the researchers to propose the concept DOP, dark oxygen production. And this figure shows that oxygen concentration, which measured by calibrated oxygen altitudes. Okay. And the different figures represent different cruises. And every lines represent different. I don't know what is this. Okay. different color line represent different experiments. For example, the green line in the 5D cruise represent dead algal biomass. And the x-axis represent incubation time, and the y-axis represent oxygen concentrations. And from these figures, we can see that the lines is increased. So we can say that oxygen concentration did not simply decrease, but showed a net increase. And this result provides direct evidence of DOP. And then is oxygen concentration measured in different regions. And the x-axis represents incubation time, and the y-axis represents oxygen concentrations. And from this figure, we can see that the lines is increased. So we can say that DOP is supported as a widespread phenomenon. And the researcher wants to rule out biological oxygen production. So they add mercuric chloride to seafloor sediment cores to kill all living organisms. And they found that oxygen production was still exist in this dead cores. So this result proves that DOP is a geochemical process, not a biological one. And this figure shows that background corrected voltage potentials on nodule surfaces. And the y-axis represents voltage, and unit is volts. And every box is under 21 degrees, except for 6 and 7 nodules. It's under 5 degrees. And the x in the box is represent mean values, and the line inside the box represent median values, and top and bottom of the box represent quartiles, and which curves represent minima and maxima. And the numbers here is represent replicate. And from these figures, we can see that the measurable potential is on all the nodules. And this figure is shows that total net oxygen production in ex situ sediment cores. And the x-axis is represent treatment conditions, and the y-axis is represent DOP. And from this figure, we can see that every box is positive. So we can say that DOP can be observed even in ex situ incubations on the ship. And then is the discussion. We know that water splitting could produce oxygen without lead in the deep sea. But the researchers meet the challenge that theoretical electrolysis of seawater requires 1.23 volts, but the measured voltage on the surface of the nodule only reached 0.95 volts. So the researchers proposed the explanation, the catalyst effect. They found that polymetallic nodules contain transition metals like manganese oxides. And these metals act as catalysts that can lower the energy barrier to make water splits could produce oxygen. And then is discussion 2 is the implication for deep sea ecosystem. Deep sea ecosystems were thought to rely on sinking organic matter before this study. But now, in this study, we know that dark oxygen production could provide an additional oxygen source. So DOP may influence deep sea biochemical cycles. And the last is conclusion. To conclude this study, researchers found that oxygen production was observed at the deep sea seafloor, and they do many experiments to confirm the presence of the next oxygen generation. And they also found that polymetallic nodules may generate electrical potential that can drive electrochemical reactions. However, I think that we need more researchers to fully understand this process. Thank you. This is my presentation.
Okay, I want to ask will dark oxygen production affect the carbon cycle?
Carbon cycle. In the study, they don't say that, but I think the carbon cycle may associate with the oxygen.
Thank you.
Do you think nodules are the main reason they are organized in the deep sea?
Can you repeat it?
Do you think nodules are the main reason they are organized in the deep sea? They are what? They are organisms in the deep sea.
Organism.
Organisms. Sorry.
Oh, no, it's a nodule. It's a polymetallic nodule. It's like a rock. It's like a rock.
I want to ask that, was oxygen generation observed in all tested locations or only some locations?
In this study, they said that the polymetallic nodules only find at the CCZ. So in other place, they don't find this
Okay,
yet.
thank you.
Yet.
So first of all, at the very beginning in your introduction, in your cover, there was already a pronunciation, abyssal. Okay, abyssal.
Okay.
Yes. And then the overall comment for your stage performance, you look quite confident, but I feel that you can use your pointer more often and you can look at them more often. You spoke fluently, but still you can, yeah. And then next time, please put your page number here. Here. I have to repeat that again and again. Upper left corner. And then the talk was interesting. However, I feel that there is something missing for this slide. That is, you talk about polymetallic nodules. However, you should say more about their occurrence. Where can we find it? Apparently not everywhere in the ocean. There's a specific place where we can find it. And also, maybe you can briefly talk about their formation mechanism, if you know that. Why we can find them here, not other place. So say something more, because your talk was a little bit too short. Add one slide talking about this nodule. And then this one is okay. And here it is nice that you show the photo of this benthic chamber, and you also color code your keywords. And this read profiling. And this is also nice. You use this kind of photo to show the experiment. And this one is okay. And however, here you started to talk about results, and there is one thing, which is you say description before you show data. It should be the other way around. Because this is evidence, right? You should show your evidence first. Then you can conclude all of your evidence with this. And when you were talking about these two slides, it was a little bit messy. So I don't know, it's jumping automatically. But next time, make sure you introduce the figure first, okay? And then you start to talk about these different things. And then here, oxygen, okay. And here you say like production of this by adding this toxic agent, mercury chloride, mercury chloride, okay? And then I was wondering where the data is, and then later I found that here you have data. So please add data before you say this. Your statement should be supported by data, not just statement. And then here you talk about the location, not this one. Location here. Are these all from the same CCZ? If yes, please tell us, because some of them were asking, did you find this in other place? Then I was thinking, does it mean other places, or are these all in CCZ? So you should clarify that point. And here you talk about voltage, and this figure was clearly explained. However, after listening to that, I was thinking, okay, so what? Then later you talk about the meaning. So my feeling is this discussion should go right after this. You need to discuss your data right after you show the data. So this one followed by this one. Then we know the logic, okay? And here you have so many different kind of ex situ experiments. Maybe you can highlight some of them. For example, what does it mean by control? And what does it mean by this? You mean this is toxin, right? So you should highlight some of them and say that all of them have a DOP. Okay. Hello.
Respect.
Right. Okay. And the conclusion is nicely done. So you see that he shortly repeat what has been said in this article. So this is a good example, conclusion. I hope you will learn from this. Overall, it's a good presentation, but I feel that you can still add something, especially about the introduction of nodule and the sequence of your slide. Okay, good. Very good. We finished 6 talks. So next week, we are expecting another 6 talks. So speakers, please come early to upload your slide. See you next week.